India has done it. It has become now the fourth country to land a spacecraft on the moon after the US and China and the former Soviet Union. What made one of the world's most brilliant physicists cry on live television? Michio Kaku has spent decades searching the stars for signs of intelligence, only to discover it was waiting just 384,000 kilometers away. India's Chandrayaan-3 didn't just land on the moon. It uncovered something impossible. Signals, symmetry, and a heat-emitting object buried in darkness. Now, Earth's greatest minds are shaken, and Dr. Kaku's emotional response says it all. We were never alone. The moment of impact on August 23, 2025, at 2005 IST, ISRO's Chandrayaan-3 reached lunar orbit and executed a flawless descent toward the moon's southern pole. India became the fourth nation after the US, USSR, and China to achieve a soft landing. But Chandrayaan-3's record differed. It arrived at the uncharted 87° latitude in permanent shadow where no rover had tread. As the lander Vikram touched down next to the rover Prague, mission control erupted with historic achievement calls. That moment marked the start of a new chapter in lunar exploration. Within 5 hours, Prague rolled off the lander ramp onto the frigid regolith surface. The terrain captured in 4K imagery revealed deep craters and jagged rocks stretching beyond 50 m in radius. Scientists had planned baseline goals analyzing lunar soil, measuring seismic activity with the onboard seismometer for lunar surface seism and searching for water ice. But instead of a dusty gray plain, instruments detected anomalies, a strange glint in crater walls and thermal readings at 173 degrees Celsius. We didn't expect anything like this, said lead engineer Dr. Mirai Au. By August 24, mission data showed something off script. Initial samples from the regolith held unexpected traces of elevated hydrogen, suggesting water ice, but also a handful of unknown minerals. The seismometer recorded microquakes at 0.02 Hz, unusual for typically quiet lunar terrain. SRO scientists switched from planned routine to cautious curiosity. The anomaly triggered automatic alert, said mission scientist Dr. Vijay Singh. What was meant to be standard soil analysis suddenly demanded deeper investigation. Within 48 hours, Chandrayaan-3's team pivoted. Perrin began surveying lunar shadows and crater depths for signs of ice and seismic variation. The target craters were slated for ice detection tests, but sensors instead picked up electromagnetic echoes, subtle pulses at 2.5 Hz, beyond expectation. The mission began to evolve from geology to something approaching EXO signal detection. The routine had shifted. A discovery off-script turned the calm landing into a scientific rupture, hinting at mysteries beneath the moon's surface. The moments after landing set the tone. Chandrayaan-3's impact was more than a national milestone. It was a gateway to the unknown. Section 2 dives into the strange signals emerging beneath the regolith. Instruments began picking up unusual density patterns, electromagnetic pulses, and reflective signatures beneath the lunar soil. Data pointed toward highly ordered structures, not random geology. As Vikram and Pragan approached, scientists buzzed with excitement and concern. The anomaly seemed to defy normal rock formations, pointing instead to something deeper and possibly artificial. The anomaly beneath. On August 25, 2025, just 48 hours after landing, Chandrayaan-3 seismometer began recording irregular underground density spikes beneath crater PSR-42, located at 87.3 degrees S22E. Initial readings indicated a mass roughly 14 m wide with 35% higher density than surrounding lunar rock. This object wasn't visible on the surface. There's something buried there, something that doesn't match lunar geology, said astrology physicist Dr. Arjun Malik. Unlike iron-rich regolith, the anomaly appeared structurally complex, perhaps metallic. Then came the magnetics. Pound's magnetometer detected rhythmic pulses at 5.1-second intervals with amplitude exceeding known lunar magnetic fluctuations by a factor of 12. These pulses continued for 19 minutes, then abruptly stopped, only to return 6 hours later at the same frequency. This isn't residual magnetism, said Dr. Malik. It behaves like a signal. It was not just strong, it was specific, as if responding to something in its environment. On August 26, ISRO's Data Relay Center compared these magnetic patterns with known EM frequencies. The reflected signals returned from beneath the anomaly-matched resonance points used in radar-based communication systems, particularly in the 8.6 to 9.1 GHz band. These are typically used in advanced data telemetry. "We weren't looking for a transmitter," said communications engineer Nolini Das. "But this thing's bouncing signals like it was designed to." Scientists flagged the object as a potential. Techno-signature structural symmetry became the final red flag. 3D imaging showed consistent geometric proportions, an elliptical structure aligned precisely 27 degrees off lunar north. This was not random fracture or mineral deposit. "It's too precise, too layered." Darrows concluded the object was not geological chaos. It was structural intent, a pattern, and perhaps something that didn't arrive naturally. The mystery deepened with every reading. Section 3 moves beyond geology damn into technology. As ISRO compared the anomaly's behavior with known physics, they realized it matched what some scientists call technosignatures. Signs of advanced engineering, the regular pulses, reflective properties, and symmetrical architecture all pointed away from natural origin. Could the structure beneath the moon be not only artificial but intelligent in design? What started as a soil survey was now brushing against the edge of contact. Not of Earth, not of nature. On August 27, 2020, a theoretical physicist, Dr. Michio Kaku, consulting with ISRO remotely from Columbia University, made a provocative statement. "These aren't geological echoes. They're techno-signatures." The term used in SY since 2009 refers to patterns in electromagnetic or structural data consistent with artificial origin. The anomaly beneath Chandrayaan-3's landing site was showing signs that met this definition. Precision signal intervals, harmonic resonance, and selective absorption across multiple wavelengths. Pion sensors began logging what appeared to be feedback loops. When it emitted test pulses in the 4.3 GA range, the structure responded with altered frequencies in the 3.9 GHz band, suggesting interaction, not reflection. "It's like sonar," explained as signal analyst Kavita Menon, "except it responds intelligently like it knows we're there." Over 16 separate tests, the anomaly demonstrated consistent variation in return signal strength as though adjusting to input stimuli. The object also exhibited selective energy absorption. When radar sweeps used S-band frequencies, absorption spiked. When switching to Ka-band at 26.5 to 40 GHz, the energy was almost entirely reflected. This selectivity hinted at deliberate filtering, a common feature in engineered antenna arrays or shielding systems. ISRO engineers began to hypothesize. Was this a sensor, a beacon, or even a shielded container? Theories diverged. Some saw it as a monitoring station, others as something long dormant but still functional. "If it's broadcasting," said Dr. Kaku, "it could be for communication or containment." The idea that it was buried with purpose in a crater bathed in darkness for 2.1 billion years sparked debate far beyond engineering circles. Was this a warning, a time capsule, or something that was never meant to be found? With signals exchanged and patterns confirmed, Section 4 examines the next phase, contact. As Prun moved closer, its systems began to misbehave. Guidance gyros faltered. Magnetic readings warped. And then came something unexpected. The structure pulsed back. Not a passive object, but an active entity or system monitoring its environment. What happened next was subtle, but unmistakable. The anomaly seemed aware, not just of presence, but of approach. The structure that watches back on August 28, 2020, as Pragyan maneuvered within 12 meters of the anomaly's edge, its gyroscopic guidance system began to fail. The onboard inertial measurement unit, IMU, logged sudden drifts of 5 to 7 degrees every 22 seconds, despite flat terrain. Over a 6-minute window, the rover's navigation had to be manually corrected 8 times. "We thought it was mechanical at first," said ISRO Systems lead Anjali Pasha, but diagnostics showed no hardware fault. Something was interfering locally. Further investigation revealed fluctuations in the rover's magnetometer data. Between 1042 and 118 UTC, magnetic field readings spiked from baseline 0.2 metric tons to 6.3 metric tons, then dropped to near zero in a waveform pattern. These weren't random distortions. They occurred only when the rover entered a defined 6 m radius near the anomaly. The pulses were also rhythmic, peaking every 445 seconds. It was as if the object emitted a perimeter response field. Then came the feedback. At 1120 UTC, Pragyan sent a simple coded ping, a binary signal used to test data transmission latency. Exactly 4.5 seconds later, it received a return signal, not an echo, a slightly altered response, a 7-bit shift from the original pattern. Over the next hour, ISRO repeated the test 14 times. Each time the signal came back modified, but consistently so. It wasn't noise, said Tabesha. It was structured. It was listening and replying. By August 29, Mission Control considered halting proximity movement. The object was no longer passive. Its emission suggested scanning behavior like LAR pings or radar sweeps. Heat sensors detected a plus 1.8 degree rise on the rover side facing the anomaly. That warming couldn't be explained by sunlight. It was still in full shadow. One mission log labeled the event simply responsive intelligence suspected. The moon was watching back. As the anomaly responded to preaching, scientists faced another enigma, its internal energy. Section 5 turns inward, examining how this object defies lunar physics. Despite being buried in a crater where temperatures plunge to 230 degrees Celsius, the structure emits warmth, and not faint background warmth, but stable persistent thermal energy. No power source was visible, no solar panels, no decay heat. Yet it endured. This wasn't just a signal emitter. It was a machine alive with unknown purpose and still running. The moon's the secret located in the Shiv Shakti Point region. The anomaly sits inside a permanently shadowed crater. Temperatures here average 173 degrees to 230 degrees, cold enough to freeze even hydrogen. Yet thermal readings from ISRO's miniaturized infrared sensor array on Prague recorded on August 29 showed the structure holding steady at 49 degrees Celsius. This wasn't residual heat. It was internally generated. "We've never seen anything on the moon this warm without sunlight," said astrothermal physicist Robbie Kotari. Scientists ruled out radioactive decay quickly. Gamma spectrometry returned null. No uranium, thorium, or potassium-40 signatures. The object emitted zero ionizing radiation, nor were there chemical reactions visible. No guts, no erosion, no particulate motion. Yet heat persisted for over 14 hours of observation. "It's like a thermos," said Dr. Kthari, "except it's heating itself in a vacuum with no visible fuel." One theory, zero-point energy, exotic, theoretical, but not impossible given the data. The surface material was equally baffling. Spectroscopy showed compounds not found in lunar rock. A reflective ceramic-like layer exhibited 95% emissivity stability, absorbing almost no external radiation while emitting thermal energy from within. "It behaves like engineered insulation," said materials analyst Dr. Ferlate Dev. She proposed a structure that used layered nanomaterials to trap and regulate energy. But where that energy came from remained a mystery. Perhaps the most astonishing hypothesis came from ISRO's AI systems, which ran simulations based on the thermal data. They suggested the structure's power source had been active for over 9,000 years, assuming stable emission at current rates. "It's still on," said Dr. Dev. "Whatever this is, it's outlasted civilizations. It's running a purpose without interruption." In silence, buried in darkness, it functioned like a lighthouse beneath the moon's skin. The discovery of internal heat challenged the very notion of lunar dormancy. Section 6 looks at the space around the anomaly, how gravity itself seems distorted above it. Chandrayaan-3 sensors logged a strange lightness, as if something hollow or repellent lay beneath. What was once dismissed as Mason noise is now being reconsidered. Could this structure house a vault, a chamber, or an ancient machine still humming beneath a shell of dust and time? Gravity out of balance. On August 30, 2020, as Praian conducted gravimetric sweeps, ISRO noticed an anomaly in surface gravity near the structure. The gravitational acceleration dropped from the local lunar average of 1.6262 Muir-Adaru to 1.49 Mariku within a 5 m radius. This dip was verified by the rover's accelerometer and confirmed via orbital measurements from the Chandrayaan-3 propulsion module at 100 km altitude. "It was unmistakable," said mission physicist Dr. Kunal Jushar. "Something down there is less dense or empty. Hollow cavities beneath the moon aren't new. NASA has long studied maskins, mass concentrations since the 1960s, but this was different. The gravitational irregularity was focused, not dispersed, and matched the exact coordinates of the thermal anomaly." ISRO's density modeling updated over 12 simulations, proposed a structure with a solid shell and an inner cavity at least 9 m in diameter. The numbers suggest not just hollowness, said Dr. Joshi, but engineered separation. The structure's materials deepened the mystery. Spectral analysis showed it was both light and dense, exhibiting high reflectivity with atomic numbers inconsistent with any known lunar elements. One material appeared similar to aerogel, yet had metallic conductivity. We're seeing a paradox, said material scientist Asha Mehta. Low mass but high structural integrity. This isn't random. It's designed. It may be shielding something inside or perhaps isolating it. Engineers now hypothesize a chamber beneath the structure, possibly a sealed vault or energy containment system. If that's the case, its gravitational footprint may result from internal pressure differentials or exotic matter. This goes beyond known physics, said Dr. Mehta. We're not measuring geology. We're measuring architecture. Chandrayaan-3's mission to survey dust and soil had uncovered something far more profound. An object that defied both weight and space. For Michio Kaku, it wasn't just science. It was a spiritual rupture. The moon, silent for millennia, has whispered something we can't unhear. As signals pulse and instruments falter, we face a truth more profound than alien life. Intelligent design older than our history. Kaku's tears weren't from fear, but reverence for a cosmos far stranger than we dreamed. Chandrayaan-3 didn't just make history. It may have unearthed the universe's oldest secret.